Okay, section 3, we're going to talk about arcs and their chords that go with them. Okay. Really just a lot of knowing why we're setting two expressions equal to each other, as opposed to what do we need to do with these two expressions. Okay. So this first one is the congruent chords theorem. So if we've got a circle or two congruent circles, two minor arcs are congruent if and only if their corresponding chords are congruent as well. Okay, so for instance, if we take this circle L over here to the right, we know that if this chord FG is congruent to the chord JH, okay, so we know these two line segments are congruent, then we can say that these minor arcs here that are kind of cut off by those chords are congruent as well. Okay, we can also say the opposite of that. Okay, if the arc FG is congruent to the arc JH, then we can say the chords, the line segments, are congruent too. Okay. So looking at some examples here, find X in each figure below. All right, we've got that chord JK there is 4 units and LM is also 4 units. So since since those chords are congruent, that means that these arcs are also congruent. Okay, so we know if the arc JK is 82 degrees, that means arc LM is also 82 degrees. So X is 82. Okay, example 2 here. We've got that these arcs RS and TV are congruent. Which means we can say that the chords RS and TV are congruent. So we want to set 5x minus 9 equal to 2x plus 3. All right, if we subtract 2x from both sides and add 9, we've got 3x equal to 12. And dividing both sides by 3, our x value is 4. Okay. I want you to try example 3 on your own, but then we are going to try example 4 together before you do 5 and 6. All right. Example 4, we've got that these two chords are congruent, RS and TS, which means that the arc RS and the arc TS are congruent. So over here is X as well. Okay. And an entire circle is 360 degrees. So if we take 360 minus the 64-degree arc that we've got down here, that leaves us with 296 degrees. And since the two arcs that we have left, RS and TS, are congruent, we need to take 296. Whoa, that's too many nines. Try that again. That 296 degrees that we have left, and cut it in half. So X in example 4 is 148 degrees. All right. Try example 5 and 6 on your own, and we're going to move on. Okay. This next theorem, if a diameter or a radius of a circle is perpendicular to a chord, so if it forms a right angle, then that radius or the diameter also bisects the chord. Okay, and its arc. So essentially, a diameter or a radius has to be the perpendicular bisector of a chord, if it's one or the other. Okay, so here we've got CB, the radius, or AB, the diameter. Since it is perpendicular to that chord XY, that also means two things: that it bisects the chord, which means XZ is congruent to YZ, okay, here. But it also means the arc that is cut off by that chord there, XY, is also bisected. Okay, so this arc here is also being cut in half, which means that the arc XB is congruent to the arc YB. Okay, so moving on to examples. Okay, we'll do example 1 together, and I want you to try 2 and 3 on your own. We can talk about it in class if you have any questions. All right, so the measure of arc P, nope, try this again. Arc PQR, okay, this little portion of the circle is 98 degrees. Okay, in our picture here, we see that QS is perpendicular to the chord PR, which means it bisects the chord and the arc. All right, so if we're looking for the measure of just arc PQ, we need to do 98 divided by 2 for a total of 49 degrees for that arc. Okay, PR is the entire length of the chord. Okay, since it is bisected and TR is 6, PT is also 6. Okay, so 6 times 2, or 6 plus 6, gives us 12. All right, so again, try examples 2 and 3 on your own. Use that information that's given to you in the problem, okay? And we will talk about them in class if we need to. Last theorem we're going to talk about for section 3 is the congruent chords theorem. And it says that if two chords are congruent if and only if they are equidistant from the center. Okay, so if we know that FG, that chord is congruent to JH, then that distance from the chord to the center, okay, and it'll be symbolized by that right angle symbol, that segment. Okay. XL is the distance from FG to the center, is going to be the same as YL. Yikes. YL. That distance from JH to the center. Okay, but we can say the opposite. If we know those distances are the same, so XL to YL, we can say that the chords are congruent. Okay, so it goes both ways. The chords are congruent, they are equidistant, but if you know that they're equidistant, then they have to be congruent. Okay. Example 1, here when we've got TH and UH both being 8, that means those distances are the same. So our chords have to be congruent. QP has to be the same as RS. All right, that's why we get to set 3x minus 4 equal to 14. Okay, add 4 to both sides. 3x equals 18. That means our x value is 6. Okay. The second example, we are given that Wx is equal to xy. So since the chords are congruent, that means they are equidistant. So those two segments there, AB and AC, have to be the same. So 5x, we will set equal to 3x plus 4. And first we're going to solve for x. All right, our x value is 2, but if we look up here, we're trying to find AB. AB is 5x. So 5 times 2 tells me that that is 10. Okay, and that is it for section 3.